So again, start at the right-hand side. This is not a restricted angle. Pi 11 pi over 6. Come all the way around, and it ends up in quadrant 4. Label this. This is your special triangle. Now this asks for a restricted angle whose tangent is the same as this. So you're in the same quadrant. Just name me this angle with the domain from negative pi over 2 to positive pi over 2. This has to have this domain. So therefore, it's the same exact location. You're in quadrant 4. But the angle has to be labeled as negative pi over 6. Not 11 pi over 6, because that's not your restricted angle. Are we seeing the difference here? Some of them are getting to be the same position. Some of them are different positions. It's the ones that have the restriction is the ones you have to be careful of. These guys, find me an angle who's 5 pi over 2. So this is 1 pi over 2, 2, 3, 4, 5 pi over 2. Brings me back to here. And this is the same place where this is restricted. So now how do I name this angle whose domain is from here to here? I name it as pi over 2. Good? I don't want any of these done on your calculators.
Where did you get, yeah. Never mind, I found it, I got it.
Okay, this guy, locate 5 pi over 4. He's not a restricted angle. I locate 5 pi over 4, he's in quadrant 3. I notice this is a 45-degree angle. I label my triangle. What is this asking me to find?
Angle whose sine is 5 pi.
An angle whose sine is whatever this happens to be. So what is the tangent for this guy? What is the tangent of 5 pi over 4? Negative. Oh, sorry, you're right. Positive 1. Positive 1. So therefore, I want a restricted angle whose sine is 1. And where is my sine restricted? From negative pi over 2 to positive pi over 2. Somewhere in here, I have to find a sine, which is my y value, of 1, which is right there. Do the right side first. Now, sometimes you don't have to go do the whole triangle thing out because sometimes it's just asking for another part of it. But when it's asking for a restricted angle, then you're going to have to work that part out.
I'm just not good at it when it's the inverse is on the inside of the parentheses.
Okay, do we have one like that?
Well, we did, but it was just the canceling out.
And here's a couple.
Oh, never mind.
Yeah, we have a couple more. Yep. So now,
Here we go.
arctan. Where do I find a tangent whose positive that's restricted to what quadrant?
1 and 4.
1 and 4. So it's everybody's positive in what quadrant?
1.
1. So right away, drop your triangle in 1. Label all the parts of your triangle. So I've got an angle in quadrant 1 that I want what? The sine. So I don't have to go find my angle. I just have to label my triangle in quadrant 1 and then find my sine, y over r. Sometimes we ask you for a function, sometimes we ask you for an angle. I think this one makes more sense because you actually locate where your restricted angle is, label your triangle, and then find another function of it. That's all you're doing. What's that?
No, it's like this one is easier because it just gives us the number, but for 53 to 63, you put it in radians, so I didn't know what to do. So I was just confused. But I just found out that you could just...
But don't pick up your calculator, that's why you were confused. Because in radians in your calculator, it's going to come out as a decimal. It's not going to come out as pi over 2. So be careful. This is what ultimately you need to look at. I need a cosine. Does cosine give me an angle or does it give me a ratio? A ratio. So therefore, I need ratios here, here, and here. No angles. I just have to locate them. This tells me where do I find this. Again, sine is positive, quadrant 1. Label your triangles. Do Pythagorean theorem, find the missing side. Cosine, x over r. It depends what you're looking for. Sometimes, yeah, we're looking for the angles. Sometimes we're just looking for another trig function. This one says, find me where this tangent is restricted when it's negative. Tangent is restricted to 1 and 4. Can't be 1, so it's got to be 4. So I only want the secant. I don't want the angle. And chances are we're not going to ask you for an angle when it's not a special triangle. Otherwise, you're going to have to pick up your calculator. So the concept is not to have to do that. So find the missing side, and then just give me the secant of this angle that's located here. And secant is the reciprocal of cosine, so r over x. Cosine is restricted to 1 and 2. Cosine's domain is from negative pi from 0 to pi. From 0 to pi. From 0 to pi. From 0 to pi. It is negative in quadrant 2. Quadrant 2 is the negative one. Quadrant 1, everybody's positive in quadrant 1. If you think about your cosine curve, that's the different one. It starts up here. So you're going to cut here. You get through quadrant 1, you're getting through quadrant 2. So 1 and 2. And if you notice it, they work out really nicely if you just look at the graph of the function. And then find the sign. Yes?
With the 0 and pi mean, why did you put that?
With this what?
You put close to negative 1, 0 and pi.
No, the domain goes from 0 to pi. The domain goes from 0 to pi of your restricted curve, of your restricted cosine curve. I just wrote it in a little shorthand there. So you're in quadrant 2 when it's negative, quadrant 1 when it's positive, because your cosine curve goes like this. It goes the opposite. Your sine and your tangent work very nicely. They work the same, almost, except for you can't use 90 for tangent. Are we okay with this? What are we looking to find ultimately? The sine. The sine of an angle whose cosine, restricted angle, is 3x. Now, a restricted cosine who's positive would be in what quadrant? 1. So right away we need to locate this guy. He's in quadrant 1. We have a little qualifier here, and we'll take a look at the little qualifier, why that happens. So we're in quadrant 1. We drop a triangle. We label cosine. Cosine is x over r. The 3x has nothing to do with the x. So 3x and r. Now we need to find the sine. We don't need to find the angle. We need to find the sine of this guy. So how do I find the missing side of a right triangle? Pythagorean theorem. Any right triangle, I find the missing side by Pythagorean theorem. What's going to happen here is, like in calculus, we don't really give you all the numbers. Sometimes you get a lot of the symbols here, so you've got to work with this. This is your 1 squared. Be careful when you square 3x. See if you can find me the missing side. That guy. He's not a perfect square. A perfect square would be 1 minus 3x times 1 minus 3x. He's the difference of perfect squares, the 1 plus the 1 minus. So both of those factors are not the same. Did everybody get that?
Yeah, I just put the square root like that.
Can't take the square root of that. Because these factors are 1 minus 3x, 1 plus 3x. They're not the same.
Yeah.
So you can't take the square root of that. Now, we know we have a domain restriction. This is where this is coming from. We know we have a domain restriction when we have a radical. Under a radical, what can it not be? Less than 0. Can't be negative. So we take this out and we say this has to be greater than or equal to 0. This is where our domain restriction comes in. The process has not changed, we just made it look a little bit worse. But you're still doing Pythagorean theorem, still going to find sine y over r, and this is going to be your y. It just looks a little worse, because it doesn't have a nice little number to it, and the problem is it has a domain restriction. So we say, okay, this is a quadratic, I do factor this like this, I find the zeros of this quadratic, and x is equal to 1/3, and x is equal to negative 1/3. I make a number line, because it's an inequality, and which way is my parabola going to turn, up or down? If it has a
Down.
negative, down.
Sorry.
So if my parabola goes like this, here's my points, it's positive above the line, so my domain is going to go from negative 1/3 to positive 1/3. But we have one other problem. What quadrant are we in?
1.
1. So can we ever be negative?
No.
No. So therefore, my domain is going to go from 0 to 1/3, which is what they put right here. They just qualified this. So we have a little domain restriction. We're going to use this side, but we have to use it with a limit here. Now, once we do all this, we find the sine. Sine of this angle is y over r. So y is this piece right here. And, sorry, and my r is 1. So my sine is this. Do we have any further domain restrictions?
Nope.
Nope. So we're good to go there. Everybody okay with that?
So that's just the answer?
That's the answer. That's the sine of an angle whose restricted cosine is in quadrant 1, and the cosine of that restricted angle is 3x.
Okay.
So same process as when you do this before. It's got the same process, except I didn't say 3, and you would find 4 or 5, and it just has a 3x. It has a variable in it. This x has nothing to do with the x that we find, or the x and the y of your graph. Now, we're going to find the cotangent of this same exact thing. But we already know where it's positioned, right? We already know that it's there. This is the same exact piece as this piece is. So we're in the same triangle. So what parts does cotangent use?
Opposite is
Give me x and y. X over y. Good. So I find my x. My x is 3x. And my y is that darling little thing. Okay. But now, what happens to my domain restriction?
changes
What do I have to change?
because it can't be equal to 0.
It can't be equal to 0. So do I have to change both the 0 and the 1/3 to be soft brackets, or just the 0, or just the 1/3?
Just 0. Oh,
If I put a 0 in here, 0 squared is 0, times 9 is 0, 1 minus 0 is 1. Is that okay?
Oh,
So what's going to happen with the 1/3? 1/3 squared is 1/9 times 9. This gives me 1, and 1 minus 1 gives me 0. So it's just the 1/3 that I have to change. So I'll go to 0, and I can go all the way up to 1/3, but I can't use 1/3.
that's tricky. That was
But we've seen this before. On the flip side of this, we didn't see it with trig because